Well, good morning, everybody. My name is Cale Harbor. I'm the product manager here at Advanced Control Solutions. This is an exciting day for us. We do have a bit of exciting new technology. It's rare that we get something that's this revolutionary to really be able to talk about, but this is really going to be a huge game changer in the world for machine vision and the way that we can solve applications that previously have been unsolvable. So with us this morning, we have Mr. Greg Seal of Cognex, who is going to be presenting the technology to us, as well as going over potential applications that this can be able to solve for us. Just a couple of little housekeeping things. I am going to be recording this to post on our YouTube channel later. So if you miss it, then, or if there's someone else in your organization that wants to see it, you can go to our YouTube channel and be able to watch that accordingly. And then let's see what I'm going to be monitoring the chat window as well. If anyone has a question that comes up or something that we need to address, please post it to the chat window. I am going to then be monitoring that. If it's something immediately relevant, I'll be interrupting Greg and we'll deal with that. If not, we're going to deal with all the other questions at the very end of the presentation. So that being said, Greg, are you online with us and ready to get started? Greg? I see Greg on the list. We have, how interesting, we have lost Greg's audio connection right quick. I see his cursor moving though. We're going to try and deal with this technical difficulty right quick. It appears that Greg's phone connection has disconnected him and he's redialing back in. So we're going to give him a minute to be able to join us right quick. For those of you who are new to Cognex or have not worked with Cognex before, they've been one of the cornerstones of ACS's offering now for many years, and they are specialists in the machine vision inspection world. So they have been able to release a variety of new technologies over the years, including their pattern recognition system, PatMax, their In-Sight smart cameras, and their ability to be able to solve traditional 2D vision type applications for many years. What we're going to be getting into this morning with the D900 is their deep learning algorithms that takes us beyond just a rules-based structure into something a little more intuitive. And I think I hear Greg on the line with us now. Are you there, Greg?
Yeah, hey, can everyone hear me okay now?
You're coming through loud and clear on my end. Thank goodness you're here and I don't have to tap dance anymore.
Yeah, sorry about that. I guess I got muted and had a little trouble unmuting, but I'm here. So yeah, thank you everyone for joining. Let's go ahead and get started. So today we'll be looking at the new In-Sight D900 deep learning smart camera. So for those of you guys who are familiar with Cognex, I'm sure you've been introduced or aware of our In-Sight platform. For those that are not, the In-Sight is a smart camera. So the idea here is that we're doing all of our processing, all of our decision making, everything on board this beautiful yellow device right here. It is an embedded system, so we do not need the use of a PC. We do not need a separate light controller, I/O board, anything like that. This camera will just sit on your PLC network or connect to a PC and communicate straight from it. As you can see, one of the benefits here, we have the Ethernet communication. We've got a power I/O cable and a light port, and that is really all you need once you have a deployed system. So what we're looking at today is the deep learning D900. So what this camera is able to do is actually make deep learning machine vision decisions on board itself. It does have an additional processor that's used for the deep learning. So this needs to be, it's a whole new device, a whole new piece of hardware. And as Cale was mentioning, this is a pretty revolutionary technology that we're seeing because of the use of deep learning is able to do a lot more in the machine vision realm So very excited to show this to you guys today. Thank you for everyone for joining, and let's get into some of the fun stuff, and I'll show you a little bit more about the deep learning. So we've got 3 main deep learning tools that we'll be presenting and discussing today. Those are ViDi Detect, ViDi Read, and ViDi Check. I'm going to show you guys a little bit about these as well. So ViDi Detect, this is a defect detection tool. And the way it works is you feed it images of what is good. So what your product is supposed to look like. And what it does is it finds anomalies or differences from the known or the good that you taught it. So what we're seeing here is a lot of advancements in able to, one, handle complex applications. A good example, if you look at the top left here, we have that medical screw. And you got a lot of glare and features and change in contrast and things like that. These are things that would really throw off a traditional system and really just not, kind of prevent you from providing a reliable inspection. Where the deep learning is able to kind of account for those differences, those changes in the features and, the changes in contrast, and overcomes that and able to see, hey, I know that this scratch isn't supposed to be there where all these ridges and things like that are. And that's one of the really strong powers of this tool, and really deep learning in general, is we're able to kind of account for variations and lighting changes, a little more complex things that a rules-based system may have struggled with. So again, ViDi Detect, you feed it good images, it learns what your product or image, really whatever it is supposed to look like, and then it finds differences from the known, from the good. So very powerful defect detection tool. The next one we have is the ViDi Read. Now this tool is basically, it's doing OCR. If anyone here has done OCR in the past, I'm sure you've experienced with some of the difficulties that come to play when deploying an OCR system. And I think all these difficulties are on display here. I mean, if you look at the top left, you've got a water bottle or some sort of bottle here with black on black text going around a curved surface. Now, those are some big no-nos if you're trying to deploy a rules-based OCR system. ViDi is able to do a really good job of learning the text, able to understand, and really it just acts like a human brain. And that's a really good rule of thumb to see if I can see a picture of it, if I can read it as a human, then I bet we can teach ViDi to read it too. Another example here on the right, you've got some fading text, you got a confusing background. These again are things where pretty difficult to do an OCR system before deep learning, but now it's something that we're able to do and able to do reliably. I think again down at the bottom you've got an IV bag. This is a pretty famous application because of the challenges that it brings up. A lot of those are talking about you got glare, you got fluttering of the film, things that are going to change the aspect ratio in the view of the text. Again, really great application for deep learning. And I've got a really nice example that I'm excited to show you all today of that. So the third tool that we're going to be looking at is the ViDi Check. And what we're going to be talking about today is for assembly verification. So the way the ViDi Check tool works, if you're familiar with Cognex, you're probably familiar with our PatMax algorithm. If you're familiar with other vision systems, it's more of like a pattern matching. And the idea here is that you teach it what a component looks like, and you feed it examples of that. And that's really important because what that does is it overcomes multiple scenarios or situations. So if your part doesn't need to be exactly oriented the camera the same exact way, you can introduce glare, you can introduce changes in aspect ratio. It could be flipped upside down potentially, and you could still teach it that that's the same part. So again, these are really things that deep learning is able to help us overcome and be able to do more with vision. So the way this tool is working, like I said, it's more like a pattern match where you teach it what something looks like, and then you can identify, find it, get the location. And kind of what we're showing here today is for assembly verification. This is something we've seen a lot of with the deep learning technology so far, is be able to look at a full assembly of parts, make sure all the components are there, they're the correct components and in the correct location. And again, the big takeaway from this, able to overcome variation and positioning, placement, and we're seeing this a lot more with more of like human operator interactions, where maybe I have a human operator packing a kit of something. They're never going to put it in the same place every time. It's a lot different than a robot doing it. So you have to be able to handle a lot more variation. And so that's kind of the idea here. All right, so we've introduced the three main tools. Let's jump into the fun stuff. I'm going to show you all the camera and show you the software and show you what we can do with it. Before I jump into the live demo, I'm going to show you kind of a up-close view of the parts we're going to look at so you can get an idea of the variation that we're able to work with here. So we've got 4 business cards with a carbon fiber print on them. And I think the big takeaway I want to show you here is that the formation of these cards or the pattern on them is all very similar, but it's different too. And I'm going to show you that as I scroll through these here. You've got different contrasts, you've got different shading, you know, you've got things that prevent you from being able to do something like this with a rules-based system. You know, if you were able to, you know, do a auto teach or some sort of pattern match on this background, once you switch to another background, well, it's not going to work anymore. So those are the 4 cards. So let's exit out of this, and I'm going to show you guys the camera. So if you don't see my webcam here, I've got a Cognex D900 right here. We've got the integrated light and an autofocus lens in it. I've got a power cable going to my 24-volt power supply. And my Ethernet is hooked up to my computer here, which will be running the software. So as we do that, let's jump into the software and show you the new look of our In-Sight Vision suites. So again, for you know, long-time Cognex users, this probably looks pretty familiar. We've got a nice view of our spreadsheet. We've got our image over here on the left. You can see we've got a nice split between the two, so it's a little bit easier to work with. And this is the software that the deep learning is going to be living in. This is not a replacement for In-Sight Explorer. This is going to be a new software for this new model of camera. And you'll see as we jump into the deep learning tools why it's nice to have this new interface, because there's a few more pages and things that we need to jump between. So what I've got here is really just a mostly blank image. We're doing a Pat Max on the logo here. As you can see, it's already found that logo. And Pat Max is just, again, it's a pattern matching algorithm that Cognex has developed and has been using for many years. And what we're actually going to do is we're going to use the Pat Max to guide our deep learning tool. And I think that's a really important takeaway here, is that we're able to use the traditional vision algorithms with our deep learning algorithms as well, or deep learning neural network, I should say. So what I'm going to do is I'm just going to go over here to my toolbox. You can see I've got vision tools. Today we're going to focus on the ViDi tools. So I'm just going to grab ViDi Detect. I'm just going to drag it into my spreadsheet. And there we go. The toolbox pops up just like that. So as I mentioned, we're going to fixture to the pattern tool. So you can see I've got my external fixture here, and I just double click on that and click on pattern. And then I'll hit enter here. So easy as that. The next thing I want to do is set up my region. So I'll double click the region. And this is just going to be where our ViDi Detect tool is going to be looking. The idea here is this region will follow the relative position of the logo, which is found by the pattern tool, the Pat Max, and that way it's always going to be on our card. So I can just place my card anywhere on my demo stand here, and it's going to be able to follow that. So I've got that set up. I'm going to hit OK. And now we've got basically our tools set up in our spreadsheet, and we're about ready to jump into the deep learning side of things. But if you can recall, deep learning learns by examples, right? So we need to take some example images. So what I'll do is I'm going to hit my record button down here at my film strip, and that should help me start taking some images. I'm going to hit a trigger here. And there you go. You can see my first good image is down there. So I'll just go through it. I'm going to take an example image or a sample of each one of our good products. And we'll be using this to teach ViDi what a good product is supposed to look like. So again, taking another one. All right. So there we go. I've got 4 good images. And now what I want to do is I want to get a bad image. So I'm just going to get a pen here. I'm just going to put it on top, and we're going to take one more image. And the reason we're doing this is, you know, ViDi Detect, it trains on the good images, but what it's going to do is it's going to get a numerical value to each one of our images. And it's basically how far from the good or, you know, that is. So we're going to use that value to determine what a good or bad product is. And so that bad image now is going to give us more of a threshold. And I'll show that in a minute when I jump into the software. So before we get into it, I'm just gonna click my first good image, and I'm gonna hold Shift to select all my other good ones. Click again. And I'm just gonna right click on all those, and I'm gonna do rename. I'm gonna hit append. So what this is gonna do is gonna put _good at the end of all the file names. And I'll show you why that's important in just a second here. I'll do the same thing for my bad image. All right. Now we are ready to jump into ViDi. So let's jump back into that ViDi Detect cell. And you can see down here, I've got Open ViDi Editor. So I click that. And as you can see, it just jumped to a new tab here. And that's really what's important, is we've got to have a new workspace to handle the ViDi. So we could, with the new In-Sight Vision Suite, we can do an HMI. We've got a full customizable web HMI with this. I'm going to jump into spreadsheet or back into my deep learning. So it's a really nice, easy way to jump between tasks here. So I'm going to go ahead and I'm going to shift click all of these images now. And I'm just going to drag them right into my ViDi workspace. And there we go. So as you can see, I'm going to zoom out for just a second. I want to show you as I scroll through these, again, just the example of the fixturing. So you can see my card is moving throughout my picture or my image, but my region is staying right there in the middle of my card, just like I want it. And that is showing off the power of being able to use the Cognex PatMax with ViDi. So again, you get deep learning plus all of our trusted algorithms with this. So in display here, I'm just going to type in quote good. And what that's going to do is going to show me only images that have good in the file name. And that's why I went through and renamed them. So I can hit action, label, good. So there you go. That's just easy as that. And the idea here is with deep learning, the more images you give it, the better the neural network typically will get, the more powerful, stronger it's going to be. So if you had a bigger image set, you want to be able to just batch label like that. Makes life a little bit easier. I could hit all here to view all of them. Click on my bad image. I can just click it once for good, second time for bad. So you can do it one by one, but if you want to save time, probably easier just do a batch label. And so there we go. We're ready to go. So we'll hit the brain to train. What that's going to do, it's going to ask me to select my training set. I'm going to hit yes. So typically when you start an application, you want to train your neural network on half of your images as a starting point. The reason being is you want to train the neural network to understand what a good product is on half, and then you want to be able to test your results on the other half. So that's why we want to train on all of them right to go, because if we did, we'd obviously get 100% for everything. So we use this as more of a test to see how good our neural network is going to be. And I'll show you an example of that in just a second. So I hit OK and randomize. And as you can see, I'm creating a model now on my PC. So this is something where you would develop your application in the deep learning space on a PC, and then you deploy it onto a camera. And again, I'll show you another example of that, as I do have a pre-trained job. It takes about 4 minutes on my laptop. But for today, I want to save a little bit of time. We'll open up the pre-trained job, and I have that loaded on my device. And then I'm going to go in and show you guys the results, show you that numerical scoring I mentioned, and that should help make it a little bit more clear of how we can see the neural network and how well it's doing, basically. So we give that a second. You can see we've already found our pen there, so we found some defect. Like I said, I want to jump back into ViDi. And there we go. So we can see down here it's giving this 11.9. And then if I look at my good images, got about a 4.9, 4.8. So it's all about 4.9 is good. I'm going to open this database view. I can see a graphical representation of that, where I can say, hey, my good product's around 4.5, and my bad's around 11.5. So now I've got a threshold just kind of right here in the middle of my image. It tells me what's good or bad. It's an easy way to kind of set that pass-fail threshold. Let's say you want to see more numerical results. I can scroll down, and I have what we call here our confusion matrix. And so what we can see is what we fed ViDi 4 good images, so actual, 4 good, and ViDi was able to predict that all 4 of those are good. So you can see 100%, that's great. And then same thing for the bad. We told ViDi that one of those was bad. Based off the neural network, retrained, ViDi was able to pick up, say, hey, that one is bad. So there we go. I mean, that's kind of how we're able to see that, the results. And that's why we test on only half at the beginning. So then we can understand, hey, is this going to be a really good application? Do I need to make some changes, feed some more images, you know, whatever you have it. But there we go. So we've got our neural network trained, our program's ready. Let's jump online. So I'm just going to hit the online button, apply my changes. And as I mentioned, I've got a web-based HMI here. So I'm going to click that, and let's give that a second to load up. I hope you can see down at the bottom right, my camera is taking images here. I'm just going to reload this for a second, get a fresh web browser. And you can see right here, we're already finding the pen, picking up some defects, saying, hey, I know that general area is bad. And here we go. And now let's take a look at it and look at some good images, look at some bad images, see what we can do with it. So obviously that's pretty simple. That's something I'm sure we could all do with traditional vision. But there we go. So now we're finding the pat max. You can see our film strip went to green, so we're good. We're saying it's a good image, which is good. Let's go here and move my finger. There we go. So again, different background, still able to say it's good. Let's take a look and see what a defect might look like. Let's flip it over and see. All right, there we go. We're finding something. Let's zoom in and take a look at that. So there we go. Just a really kind of small abnormality from our you know, our background grain or whatever you want to call it. You can say that we know that this should be kind of a black streak here, but it's got some gray. Pretty small, simple defect. And I do want to ask people, and this is kind of more of a general question, since I know we have a lot of people on the line, but if you've programmed a vision system before, I want you to think about how would you find this defect with this background with traditional rules-based system. And that's one I haven't, you know, I've been asking that to a lot of people and I have not gotten a good answer, myself included. To be honest, this is probably something I'd have to walk away from if I was trying to do that. But let's take a look at some more pictures, make that view bigger. So again, back to another good one. Move my finger, passing the green. Again, different background, saying, hey, I know that's still good. What about that? All right, whole different defect, different side of the card, circling it, and we're finding it again. So we're handling different backgrounds, different patterns, and we're able to learn the trend of how it looks and see, hey, that's different. Let's go a little bit further with it. Why don't we? Go back. I'm going to show you this is good. Picking that up good. Move that to the center. Obviously, my fingers are bad. You don't want those in there. And you can see we're back to a good one. What happens if I take this card up to the screen, see if it's looking good? Let's just kind of put a little you know, bend in the background there. Kind of see that there on the screen. All right. Well, look at ViDi right there. It said, hey, you did not teach me that this card has this kind of bend in it. I'll zoom in a little bit so you can see. You know, that is not right. That's bad. So that's the thing, is we're finding defects that we didn't even, you know, maybe even knew we were making because we learned off a good product. Typically in manufacturing, you want to make the same exact product in spec over and over and over again. This tool is able to find differences and defects outside of that good or that known. So, you know, you deploy a system like this, and this camera might be the first one in your plant to know you've introduced a new defect into your process. Hopefully that happens, but in the real world, we all have these kind of situations. I do want to show one more example of this while I have everyone here. I actually found a card with a defect on it. So we'll go back to the OK3. I can kind of show you, hey, we're passing OK3. And I'm not going to name who printed these, but I did get one, if you can see. One was a little misprint that I found here. Kind of show you. Let's see how that looks, and let's see if ViDi can find that. All right, look at that. Just a tiny little misprint. There it is. We're able to find it, saying, hey, that's not what you taught me. That is different. And that is a real defect that was given to me on these cards. And I thought that was just a really neat example that I wanted to show. So there you go. Any difference, you know, from what you taught it, you're not making the same product, you're going to find it. ViDi Detect, very powerful defect detection tool.
Hey, Greg.
So, yeah.
We've had a question come into us. Brad has asked, how large of an area can this camera be able to view?
a great question. So one thing I didn't mention is this camera is going to come out in 2.3 megapixel and 5 megapixel. So that's the amount of pixels in the sensor. So that's your resolution. And then outside of that is you can use lensing to see how big or how small you want. So theoretically, you could basically see forever, but you're going to get very poor resolution with that. So that's something that you'd want to kind of discuss with your local Cognex sales engineer, and they can help you understand based off how big you need to see, how much detail you can get. And then again, I'll give you guys my contact info at the end of this demonstration, and I'd be happy to discuss any applications further in detail. But yeah,
So
typically it'll depend on the resolution.
So basically the size of the defect comes into play as well. The larger the defect, the larger potential area, the smaller the defect, the smaller the field of view might have to be.
Yes, that sounds good. Yep. So again, it's more application specific, but that's something that you know, myself and my colleagues would definitely be willing to help look into and help you understand based off your specific application how much detail you can find with that. All right, so we've done the ViDi Detect. I do have one more example I want to show everyone here, and that is going to be the OCR. So I'm just going to do a little bit of maneuvering here on my demonstration stance and loading up a new job file. And so for today, what I'll show is if you can look down at the bottom right, we have a water bottle here with some clear text and a couple symbols. And what we're going to do is see what we can read with that. So let's put this down here and check it out. So anyone that has done OCR before will probably really enjoy this here to show, because this is something that I think if you tried to do with a traditional system would just not be possible. Now we're able to handle fluctuation in size, position, glare, background, all that fun stuff. And we're not even skipping a beat here. Just to show you guys, I cover that up. You can see it's not reading everything. It's only reading the letters. That is next level OCR. Lost my fixture there, moves it out of the way. The OCR still reading. And we're able to pick up crazy background. We got bubbles, things like that. But the OCR is not missing a beat. So this is a really nice tool, kind of bringing to a lot more possibilities in terms of what OCR is able to do. It's going to make reading human readable text, much more reliable in the machine vision industry. So very excited for this one as well. All right. So there's our demonstration. I will jump back into this PowerPoint for just a quick minute here. And I do want to mention, one other thing I do want to mention is that although this is a brand new technology for the In-Sight platform, this is not a brand new technology in terms of deep learning or ViDi. ViDi's been in our PC software for about 3 years now. And that's kind of what brought the push to bring it to the In-Sight is all the success and new applications we've been able to handle and solve with this. And as we can see, just some examples here. I'm not going to dive into too many of these for today. I do want to show an example of the ViDi Check tool. And this is a kit, again, with different medical components. And as we can see here, we're finding them, identifying them, and we'll just show a quick video of this to show how the ViDi Check for assembly verification works. And then I think the big takeaway, as you can see, all the glare, all the changing, contrast, the way it's presented to the camera can handle so much more deep learning. That's really one of the biggest, pushes and things we've seen is this able to handle variation, pick up differences. And that's because you're teaching it by example. You can feed it multiple scenarios and things like that. So just so you can see, we're moving through, showing some of the different components we're finding. Just jump ahead a little bit here just to show it in action. Yep, show some more here. And you can see, again, we're also showing the web-based HMI. Basically anything you can put in the spreadsheet, you can pull and control. What they were doing there was saying, hey, we want to find, every component but the syringe, and you can customize that from the web HMI. Comes included with the camera, anything connected on the same PLC network or Ethernet network can access it, view what's going on, and you can control how much you want the operator or the user to control on the camera as well. So a very nice, exciting feature with it that's coming, or that's in the camera. And that's what I had for today. Did want to open the floor if there are any questions or any follow-up comments that we have today.
There's currently no additional questions in the chat room right now. If anybody does have something they would like Greg to be able to speak on specifically or detailed questions, please feel free to either send it to the chat room or just unmute yourself right quick and you can be able to ask it.
Also, I'm showing my contact info here. Obviously, you can contact Enhanced Control Solutions. But if you're in Georgia, I'm happy to help. If you're outside of Georgia, I can also get you in contact with the correct person that can help with your application and dive a little bit deeper in understanding what we can do with the system. So,
all right, we did have a question come in. Is there an emulator available?
Yes, great question. So the In-Sight Vision Suite does have an emulator that you can run with it. You will need a training dongle, which is like our software license for the emulator. You can train multiple programs, multiple cameras, multiple neural networks with one license, but you do require a software license, which is just a USB dongle to run the emulator and run ViDi. And I would be happy to speak kind of offline in a little bit more detail on how you can acquire one of those.
Okay. Just as a side note, we are going to be following up with everyone who attends today to email some information to you on how you can acquire the training dongle and the developer's kit for that. There's some special offers that we can do on that. We'll be reaching out to each person individual. Also, we had another question come in. Can you adjust the AI settings?
Yes. So that score you can adjust in the neural network. You can also pull anything in terms of results into the spreadsheet, and you could adjust it, view it, do all that in the Web HMI. That's a really good question. So you don't need to use that threshold in the neural network. You can kind of have it right in the middle, and you can pull those values out and adjust it, again, from the spreadsheet, from the HMI. So anything that we pulled from the neural network or from those results is available in the spreadsheet as well. So again, that's one, I think one of the big powers of using the spreadsheet interface for machine vision programming is the manipulation of the control of so much data that's at your hands with it. So that's another really good question. Thank you.
Okay. Another question that came in. On the OCR application, you had a graphic before and after the numbers. Is that required to orient the numbers?
No. So for that certain application, we're using the two graphics as fixturing. So typically, you still want to use a fixture similar to traditional OCR. Same how within the ViDi Detect, where we fixtured off the PatMax. Because the water bottle was all over the place, we wanted that fixture to tell us where the text was. You could use the entire region as looking for text, but then that can add some interferences and things like that. So I would treat that again on an application-specific basis. But yes, those were actually our fixtures for that application.
Okay. Next question that came in. Are there software limitations of the D900 system as compared to the computer-based ViDi system?
I'm not sure what software limitations. I mean, obviously you're limited in the realm of what it can do in terms of performance, and that's again on an application-specific basis, and then also processing time as well. Obviously, the PC world is going to be a little bit faster because you can upgrade graphics cards, and those are accelerating at a quick pace. Where you're set with what we've got in the hardware on the camera. So if you are talking about more of speed limitations, I would, the PC is going to be a little bit quicker. But yeah, that's kind of, I don't know, did I help answer that question? Let me know if there's
I think so. Are the same software tools as far as being able to do the detection, the OCR? There's no difference in the algorithms, is there?
Yes, it's the same ViDi suite. What I showed today, what we call the ViDi app tools. That was the ViDi Detect, the ViDi Read, and the ViDi Check. There's also a model of the camera which has the entire ViDi suite available in it too. So if you're familiar with the PC ViDi and you want to use the ViDi Red unsupervised or something like that, or the ViDi Green, There is a model of the camera that has that as well. So you can do both. It's just, these are the three main tools that we've seen the most applications with. So those are kind of what we're starting with in terms of presenting. But yes, there's a full ViDi suite available with this camera too.
Okay. All right, that's got us caught up to date on questions right now. Anybody else have something else that we have not addressed that you would like to get asked while we've got Greg online with us this morning? All right, as I'm watching for those questions to come in, I want to thank Greg for your time this morning. Thank you for walking us through this technology. It's definitely a new arena that we've not had available before to solve things that previously were unsolvable. For everyone who's attending, ACS is set up in our test lab as well as with Greg to be able to test product. If you have parts, kits, an OCR application, we would love to get the chance to be able to get some parts in, actually run a performance report for you, get the testing done, and get the results back to you. Right now, while we're in this mode of the remote work, we're not fully quite out of the virus issue right now. We can easily set up a web-based feasibility study and prove out for you, taking advantage of our labs at ACS or even with what Greg has to offer. So you can reach out to us, send those parts in. To reach us, you can shoot us an email at info@acs-ga.com. Be more than happy to set up a time to link up with you to get those parts in and do an analysis or a detailed test. All right, I'm still not seeing any other questions come in, so I think that about wraps us up. But before everyone goes, let me just thank you again for attending and being part of what we have today and showing the D900.